Thank you very much, Giovanna and Fernando, for the invitation. I'm very glad to be here talking to you all about basically our university, Universidad de Antioquia, and our aerospace engineering undergraduate program. So let's go into the matter of this presentation. Basically, Universidad of Antioquia is a public institution. It is located, its main campus on the city of Medellín, which is the second largest city in Colombia. It's probably the oldest public university in the country, founded in 1803. And it has at least 36,000 students in all the campuses that we have. We have 12 of them. And it has almost 26 schools, 82 undergraduate programs, 42 masters. And it's basically the fields of knowledge that we can imagine the university has tackled to teach their students. Now, our undergraduate program, it's located in the East Campus of the university. I mean, it's located near the Aeropuerto, the airport that is serves the city of Medellín, which is José María Córdoba, in the city of Rio Negro. And there is where our undergraduate program is located. And it's part of the Department of Mechanical Engineering of the Faculty of Engineering. It is the first undergraduate program in aerospace engineering specifically. With that name, the first students will graduate this year in the second semester. It was founded in 2017. And now we have almost 160 students, active students in the program from the first semester until the last one. They are like around 6 or 7 students that will graduate this year. So basically we are focusing our undergraduate program around different fields of knowledge. As an engineer program, you focus on the basic science of engineering, the engineering specific sciences and areas, which are divided in basically 3 of them, which are the mechanical sciences, the electronical engineering sciences, and the software engineering sciences, because nowadays the aerospace sector is very prone to have this kind of information in their undergraduate students. And also they have the other skills that are said to be fundamental, such as the language skills. They need to learn at least another language. And also the economical part of it, because as you can see now, it's not only about launching and creating space mission, but also the new space era of commercial space is very thriving at the moment. So our space-oriented content in the program it's divided in 2 lines. As I may say, first of it is the astronautic line of it, which is focusing on the astrodynamics and attitude controls sciences. Also the space mission analysis and design, which now we see our student as basically as engineers focusing on the space systems integration, aerospace systems integration, which you can see the space vehicle and spacecraft engineering it's required to develop. And also we have interesting spacecraft and rocket propulsion. Basically now you need to have control over your assets in space, not only to put them and work with them, but also to the orbit and control the last part of the mission, like as we call it, the post-mission disposal procedure. And on the aeronautics part of it is basically the development of aircraft operation, propulsion. And also we focus on the rotary and fixed wing aircraft design, We are trying for the students to develop the skills of like drone design and helicopter design and aircraft design. We will talk about it a little bit later about the challenges that they have faced in these sections of their career. And also, it's very important to have some kind of human factors in aviation regarding the maintenance of it and operations of it, which are very particular in this case, because you need to have standards for regulating all the systems working together. Our research is mainly focused from our group, a research group, which is called Astra. Astra has 3 lines at the moment, focusing from the hotbeds that we have. One of them is Voyager, which is focused on the avionics and space vehicle systems integration. It could be aeronautics or astronautics systems for it. Let's say, for example, they are now working on a challenge that they will participate in April, that is called Design, Build, and Fly, the DBF, which is an international challenge, and they are building an aircraft from scratch. The other one is Delta V, which is a hotbed that is focused on the rocketry and propulsion in general. They work on as well as the aeronautics and the astronautic systems. And now we're trying to establish some sort of specific focus on the spacecraft propulsion, as I mentioned before, miniaturizing the propulsion and simplifying it for let's say small satellites. And we have a third one that is focused on the space debris and space sustainability sciences, which basically is working on searching for the technologies and the methodologies for having a more responsible way of exploiting space. Since we have, you have seen a brief of different situations that have been presented recently, and we are trying to implement that on the formation and the studies of our students. So if we go to the if we go to the activities that students have done, because as you can see, we are just having we will have the first aerospace engineers this year. All these challenges have been developed by the undergrad students. And the first of them were like challenges that they presented on local and international participation. One of them is the CANSAT Colombia 2020, which is repeatedly organized, and they need to focus on the design of and innovate on this type of technologies of these miniature satellites. And also they participate with different teams around it. So our students are very eager to participate and to conduct this kind of activities, not only within their like career group, but also with other universities in Colombia and internationally as well. So these challenges were like very successful for like first time the students participate, and also being a almost brand new undergrad course. The other one was the AEAA challenge, which is basically a space challenge that they have to need to design a mission for Mars activity. They needed to design a mission to go to Mars, have an orbiter, and from the orbiter they need to put a rover on the surface and gather some soil samples and retrieve them to the Earth. Kind of like the way, seeing like different sizes of it, of course, the way Perseverance will wait for the mission to return. And then they kind of segregated all the process. I mean, they created an orbit mechanical team. They created like a landing and creating the lander and how they will retrieve the samples, and also how they will extract the samples and also put them in a rocket from the rover, and the rocket will get into the orbiter and return to Earth. So it was complete exercise directed by them. They just had some kind of advisors in different fields, and science fields, orbital mechanic fields, systems engineering, product and project management. So it was a very interesting exercise to do. They got the third place globally, I mean, in the challenge. And for us, it's something very proud to be, because it's like the first time they were participating abroad. And they just participated in the SAGI IAS race, with which they got the first place. And these were students from the second year in the program. So it's very satisfactory for us. And just to finalize the presentation, I would like to present two projects that we are working on. Basically, we're trying to cooperate with anyone that has an idea that we can put our effort in. First of all is with Universidad de los Andes, which we are creating a course, a module between both universities about spacecraft control and systems engineering. Professor Fernando is one of the lecturers of it. I'm the other one. And we'll try to implement this kind of modules with other universities, not only in Colombia, but globally. And this is a module that is going on at the moment. So we have like a hybrid participation of the students. Some of them can go to the classroom, the other ones can connect virtually. And it's the idea is for all of them to work together in teams, with teams that are mixed from the two institutions. And the other one refers to it's like a suborbital committee for launching missions into like the atmosphere, basically with sounding rockets. And the institutions that are involved at the moment are like the Universidad de los Andes, the COXA, which is the scientific committee of the aerospace sector, Universidad of Antioquia, us, and from the government, there are three institutions. One of them is Indomil, which is the research about like handling and explosives and manufacturing the propellant for the rockets. SIAC, which is the corporation that is around the aerospace development from the government. And of course, the Air Force, Colombian Air Force, which leads the operation of space activities, and they will conduct all the governmental approval and permission for this idea. The idea in a few years is to have at least a rocket that reaches 100 kilometers in height, and that put a payload on it to do some research. So that's the idea we have with our undergraduate program. If you have any questions, please write us at that email you can see. We are very eager to work with anyone that wants to have like a cooperative idea. And thank you very much for everything that you presented us today with. Have a nice day.